Okay, number 1, write the following in exponential form. Okay, well, before I actually do this problem, I'm going to do a quick review. Say you have something like the cube root of x. Instead of writing that with a radical, how else could you rewrite it? X to the 1/3. Okay, so instead of the fourth root of x, you could rewrite that as x to the 1/4. So instead of the square root of x, that could be rewritten as x to the 1/2. Where'd the 2 come from? Right, it's called the square root because there's an understood 2 there. Okay, so using that information, we're dealing with the cube root, but not of x, it's of 2 to the 5th power. So, I'm going to take that 2 to the 5th power, but instead of cube rooting it, I'm going to raise it to the 1/3 power. Now we have a power raised to another power. What do we do with those two exponents? Well, we multiply them, okay? And so 5 times 1/3 is 5/3. So you end up with 2 raised to the 5/3. Okay, so I'm going to give you like 10 seconds to try B. Okay, the first thing you should have done is taken this 7 cubed out of the root, out of the fourth root, and raised it to the 1/4. But now you have a power raised to another power, so you multiply them, and you end up with 7 raised to the 3/4 power. Any questions about those? All right, number 2 is just the opposite. They give them to you in exponential form. They want you to write them in radical form. So they want you to put the root back on them. So this 5x, what root is it? The cube root. Okay, because think about it. If it were 5x to the 1/3, wouldn't that be rewritten as the cube root of 5x? Okay, let me say that again. If it were 5x to the 1/3, couldn't that be rewritten as the cube root of 5x? So if it ended up being 4/3, that just means that it was all raised to the 4th power, and so they ended up having to do the power to the power thing and multiply. You try B. So many noises in here. Okay, this is what you should have got. The 5th root of 3x all raised to the 2nd power. Is that what you got? Okay, moving on. Number 3, graph the following functions. List the characteristics on the lines provided. Okay, so the first thing I'm going to do is I'm going to graph it in the calculator. So y equals, parenthesis, 2 raised to the x power, close parenthesis, and then subtract 4. Okay, they want us to graph it. So the first thing I need to know is, where is the asymptote? Okay, let's zoom in so we can see it a little bit bigger. -1, -2, -3. That's touching -3. Do we ever touch the asymptote? Does the graph ever actually reach it? No. So the asymptote's actually one below it at -4. See how right there it approaches this invisible boundary that I'm drawing in, but it never touches it? So the asymptote is actually at -4. And doesn't that asymptote go through the y-axis at -4? So you would write it as y equals -4. Right. That's the equation of the asymptote. It's a line that goes through the y-axis at -4. Now, where is the y-intercept? negative 3. If you're not sure, watch. Hit trace. And it tells you when x is 0, y is negative 3. So that's your y-intercept. 0, negative 3. Okay, so I could go ahead and plot that point. 0, negative 3. Now, how is it that I can find some other points? Right, well, and I've already hit trace, so I don't have to hit it again. I could type in like 1 for x equals 1 and find out this point. So 1, and then enter, it's at negative 2. So I can plot the point, right 1, down 2. Then I can continue finding points that way. Now I could plug in 2 for x, and the y value is 0. What is that point known as? The x-intercept. Good. It's where the graph crosses the x-axis. Well, I clicked it. You only have to click it once, and you don't have to click it each time. Now I'm going to type in 3, enter. And I have a point at 3, 4. So right 3, up 4. Okay, and that's really enough point for this side of the curve to be able to do a sketch of it. Now I need to know what it looks like over here. So what kind of x value should I be plugging in? Negative. So like negative 1, enter. Negative 3.5. So I go left 1, down 3.5. It'll be multiple choice, so you'll pick the right one. Okay, and then negative 2. Negative 3.75. So left 2, down 3 3/4. And then negative 3. What do you notice is happening? As I go further and further to the left, what's it getting closer to on the y? Negative 4. Look, negative 3.98. If I go further left, negative 3.99. If I go further left, negative 3. It just gets closer and closer to negative 4, but it never touches it. Look what will happen if I type in something like x equals negative 100. Look what happens. Why is that? Okay, because isn't that is so far to the left and is so close to negative 4 that they can't even approximate. It's like scientific notation pretty much. It's so close. So that's enough points to just draw in the rest of it. We just know that it pretty much goes right along that asymptote without ever touching it or going below it. Yes? That's the y-intercept. Think of when you hear the word domain. For every single graph, you think that. No. The x-axis. So, we want to know, like, how far left will this function go? Forever left, which is negative infinity. Okay? As it's going up, isn't it also slightly moving right as well? How far will it continue to go right? Forever. Okay, but okay, now the range. What do you think of when you hear the word range? The y-axis. So which direction do we go first, up or down? Down. If you're on this curve, how far down does the curve go on the y-axis? Negative 4. It will never go below negative 4 because there's an asymptote there. So you could never go to negative 5 or negative 6 or negative 7. How far up will it go? Forever, so infinity. Is this a growth or a decay? Growth. You can see that in two ways. You can see that it's going up from left to right, or you can see that the b value of it is 2. And when your b value is greater than 1, it's a growth. Now let me show you another little hint. Remember, all exponential functions are in the form y equals a times b to the x plus k, correct? Alright, so look at this equation. What is in the a place? A 1. There's a 1 out here in the a place. What's in the k place? What happens when you combine your a and your k? 1 minus 4. You get negative 3, which is the y-intercept, correct? Alright, let's look at B. Is this going to be a growth or decay? Decay. The reason I know that is because the B value is less than 1. Your B value is 1/2. Now, when you type it in, you need to fix something. That X actually needs to go on the outside of the parentheses. Okay, because otherwise it thinks you're raising X to, it only thinks you're raising the 1 to the X. And we're raising 1/2 to the X, so you need to put it outside the parentheses. So let's graph it first. Y equals 3 parentheses 1/2 all raised to the X power. That's why the X has to go on the outside. Now we graph it. And where is the asymptote? Where is that curve kind of leveling out? 0. Okay, and isn't the asymptote an invisible boundary line that crosses through the y-axis at 0? It doesn't. It doesn't go below 0. So it's y equals 0. Now, the reason I know for sure that it's at 0 is because k. What was in the k value over here? -4, which is why your asymptote was a -4. What's in the k value over here? 0. That's how I know my asymptote's a 0. And it's a decay because the B value, which is 1/2, was less than 1. Okay, where is the y-intercept? +3. If you're not sure, when you first hit trace, it'll tell you. When x equals 0, y equals 3, that's your y-intercept, 0, 3. Okay, so we could go ahead and plot that point. Now, remember the little hint I showed you a while ago? What's the A value of this one? What's the K value? What happens when you combine those? You get a... What happens when you combine the A and the K? 3. 3 plus 0 is 3, which is our y-intercept, right? Your A and your K combined will always tell you where your y-intercept is. Now, we need to find some other points, because all I know right now is the y-intercept. So how do I find other points? Right, I've already hit trace to find the y-intercept, so I don't have to hit it again. I can type in like 1. 1.5. So right 1, up 1.5. Then I'll type in 2. And I get 2.75. So right 2, up 0.75. Then I'll type in 3. And I get 0.375. What do you notice as I'm typing in numbers on the right side? They're getting closer and closer to 0, which is where the asymptote is. Now, I also need to know where the exponential curve is over here, so what do I need to plug in to find those? Negative numbers, like -1. There's a point at -1, +6. -1, +6. And then I can type in -2. And its y value is 12, so it goes a little bit off, but you can kind of guess where it would be about right there. Okay, so now that we have a sketch, what is the domain? To positive infinity. Isn't that the domain for any exponential function? Because think about it. With exponential functions, the asymptote's always a horizontal line. Well, if you have a horizontal boundary, does that affect how far left and right you can go? No, think about it. If there's a horizontal line that's a boundary for you, that doesn't affect you going left or right. It only affects you going up or down, correct? So that's why with exponentials, the domain will always be negative to positive infinity. And the range will always be affected by the asymptote. So for this one, you can only go down to, but you can go up forever. Okay, any questions so far? Now, both of these are exponential functions. Okay, the asymptotes were horizontal, the domain was all real numbers, the range was affected by the asymptote. Now we're going to work on a logarithmic function, which is the inverse. So everything's going to kind of just be the opposite. Instead of a horizontal asymptote, we're going to have a vertical asymptote, which means this time the domain is affected, because a vertical line will affect how far you can go left and right, correct? But it will not affect how you go up and down. So it's this one where your range is all real numbers. And since your asymptote is now vertical, it's going to be x equals wherever it is. Okay, so let's graph it and see. Okay, so y equals, how do I type in log base 5? Math, alpha math. Or just go down until you get to a. And then base 5 of x minus 1. Oops, I forgot the x. No, because that button is a log base 10, and ours was log base 5, so that's why we had to go in to change the base. And then plus 2. Now, even though the calculator does not show it, this logarithmic function does continue to go down like this. It just doesn't do it. So, can you see where it turns at the asymptote? Where is the asymptote? Positive 1. Now, I could have looked right here, and since this is x minus 1, that lets me know that the asymptote's at positive 1. So I'm going to draw in my asymptote at positive 1. Now, a vertical boundary line will affect the domain, because it's obviously going to keep you from going left or right forever, correct? So, let's get some points. How do I get points? Trace. And then, let's look what happens if I plug in 1 for my first x value. Why is that? That's where the asymptote is, and you're not going to have a point on the asymptote part. It doesn't touch it. So maybe let's start with 2. 2 would be my first point. So right 2, up 2. Oops, I went up 3. Hold on. Okay, then maybe try 3. I don't really want to try to plot that. So try 4. I don't want to plot that either. 5. No, 6 is where you'll get your next nice point. 6, 3. So right 6, up 3. Okay, now I can draw in my logarithmic function. Now keep in mind, even though the calculator doesn't show it, it does approach the asymptote forever. And so obviously that asymptote is going to keep it from going left forever. How far left can it go? 1. How far right can it go? So are you kind of starting to understand why with exponentials the domain is all real numbers? Because the asymptote is horizontal, so you can go left and right forever. But with logs, the asymptote is vertical, so the range is all real numbers. Because a vertical boundary doesn't keep you from going up and down forever, does it? Okay, next page. What is the domain and range of this exponential function? Okay, well let's graph it and look at a picture of it. Y equals 3 raised to the x power plus 4. Okay, what's the domain? It's an exponential function, so before we even graphed it, you should know the domain is what? Negative infinity to positive infinity. Remember, this curve goes left forever, and it goes, as it goes up, isn't it also going right forever? All exponential functions have a domain of all real numbers. So C and D were out because I knew the domain had to be all real numbers because it's exponential. Now the range is affected by the asymptote, which is at 4. So how far down will this curve go? 4, how high can it go? Forever, so that would be B. Okay, so number 5, same kind of question, but this time it's a logarithmic function. So, okay, A and B are out. How do we know? Because with logarithmic functions, it's the range that's all real numbers. Because they have a vertical asymptote, but a vertical boundary doesn't keep you from going up and down forever. So now we just have to decide which range is correct. So let's look at the graph. Log base 5 of x minus 1 plus 3. And when we graph it, we see the asymptote is at what number? Positive 1. So positive 1 to infinity. Oh, no. Positive 1 to infinity. C. Okay? Because you can go left till you get to 1. You can't go any further left than 1 because that's where the asymptote is, but you can go right forever. All right, number 6. Which equation models exponential growth? Well, what do you know about that? How do you determine if it's growth or decay? What's more than 1? The b value. Well, in the b value, what's raised to the exponent each time? So, which one of those is greater than 1? B. Okay, for 7, which equation models exponential decay? B is. It's the only one. That's no B. Oh, because it's 0.23. That's like 23 cents. Okay, 7. Which one models decay? C. That's the only one that's less than 1. Okay, remember for decay, it has to be less than 1 but greater than 0. It'll never be a negative number, your B value won't be, but it could be less than 1, which means it's a decay. Okay, number 8. Where is the asymptote and the y-intercept for this exponential function? -2. The k tells you where the asymptote is. So the asymptote's -2. So you pretty much know the answer now. But remember that little cheat method I taught you earlier? What's the a value for this function? 1. There's an understood 1 out here in the a place. Can't you combine the a and the k? 1 minus 2 is -1, and that'll let you know where your y-intercept is. If you can't remember that, just graph it and look for where the y-intercept is. You add your a and your k, like a is 1, k is -2, 1 plus -2 is -1, which is your y-intercept. And if you can't remember that little method, you just need to graph it and look at the picture to figure out these. Okay, number 9. A population of 2,500 bacteria is growing at a rate of 10% per day. Use A equals P times 1 plus R to the T power and write an equation that will give you the number of bacteria present per day. So A equals, what do we put in the P place? Right, that's your start value. And then times 1 plus. Why is it plus? Growing, it's a growth. And what is the R? 0.10 for 10%. And then raised to the T for time. Which in B they tell you is 10 days. So you'll just plug in 10 and then you'll know what A equals. So everybody type it in. Yep. Yeah, I guess. Okay, what'd you get? He texts me something every time I send y'all a text.
Oh, I can take back.
Yes, it
Oh,
says,
I ain't know that.
It says at the bottom you can respond.
I can also remove you from the group. Number 10. If you purchased a computer for $1,000 and it depreciates in value every year by 20%, in how many years will the computer be worth $200? Use A equals P times 1 minus R to the T power and logarithms to solve for T. Why is it now minus instead of plus? It's a decay. It's depreciating. It's losing value. So let's set up the equation first. A equals, what's the starting value? 1,000 is what you paid for it, so that's the start value. Times 1 minus, right, to the T. We don't know the time. That's what we're trying to figure out. And we're trying to figure out how long it will take till what happens? Till it's 200. So can we go ahead and say until the equation equals 200? So what are you going to do to figure this out? Okay, so start with 2. Plug in a 2 for the T and see what you get. Everybody plug it in. What do you get? Okay, is that 200? No, so let's go on to 7. Plug in 7 and see what you get. Which is pretty darn close to 200, right? So it's between 7 and 8 years that it'll depreciate to that amount. Now, I do have some people in here who are math people, so for those people, I'm going to show you how this problem would have been worked without choices. Okay? everybody in here will understand it because we've worked plenty of these. You might just not have had the idea to start it. For one, does everybody understand why I replaced the A with 200? Well, because that's what you're waiting to see how long, so what needs to go in there to make the car worth $200. So till it equals 200, right? So we just plugged in numbers until we got close to 200. But there's another way you could do this if you don't have numbers to plug in. You could start by isolating the t. Well, to get t by itself, I'm first going to divide by 1,000. That becomes 0.2. Now over here, instead of continuing to write it like that, what is 1 minus 0.20? 0.80. Now some of you will probably recognize this as exponential form, y equals b to the x. We learned how to isolate this variable and get it by itself by changing it to log form. Okay, so that would become log base 0.80, because that's your b, of 0.2 equals t. So now I've solved for t, I just need to evaluate it. What is that in the calculator? Type it in.
But in the end,
Okay, what do you get? No. Obviously has to be between 7 and 8 now.
oh,
Over 200.
7.21. So about 7.21 years, it'll be worth $200. Now I know all of you are probably just going to plug in tomorrow, and that's fine. But do you understand what I just did? I mean Wednesday. Okay, but I mean, doesn't that make sense? Okay, let's move on. All right, number 11. Solve log base 3 of x minus 2 equals 2. Any ideas where we'll start? Well, it's already minus 2.
Maybe a plus 2.
Add the 2, because it can be combined with that 2. And now we have log base 3 of x equals 4. Now remember, our goal is to get x by itself. So what can we do to get x by itself? This is not natural log, this is common log. So when we change it to exponential, it won't be base e, it'll be base 3 to the 4th power equals x. Y'all remember that? And what is 3 to the 4th power? Y'all, 3 to the 4th power, isn't that like 3 squared times 3 squared? You're right. 9 times 9, 81. Now, for those of you who look at this tomorrow and are clueless where to start, you will have 4 choices. All you got to do is plug them in. Or not tomorrow, Wednesday. You all know what I mean. Okay, look. Log base, so I need to pull that up, 3. I've just discovered that the x equals 81, so I'm checking to make sure it's right. Minus 2. If I'm right, what should the calculator say when I hit enter? And it does. So that's how I know I'm right. Now, that's what you would do if you don't know how to work the problem the right way. You would plug in A, B, C, and D until you got the one that equaled 2. But that could take you longer than just knowing how to do the work. Okay, D, we're dealing with a natural log. So what do we have to do? E, you do E raised to all that and E raised to the 4th power. And why are we doing that? They're inverses, so those two cancel each other out, leaving x plus 2 equals e to the 4th. And didn't that get us one step closer to having x by itself? Now, what's the last thing to do to get x by itself? Minus the 2. And so x equals e to the 4th minus 2, which we'll just type in. I had to subtract it. Okay, so look. To put the e on the calculator, you do second ln. Raise it to the 4th power, and then subtract 2. And you get 52.59, so 52.6. Okay, now you could also check this. Okay, watch me check it. ln, I go back to the original question when I check it. And I type in ln, parenthesis, they did the parenthesis for me, x, which I'm saying is 52.6, and then plus 2. If I'm right about my x value, what should I get? 4, and I did. Why is it a teeny bit off? Rounding. I didn't type in 52.59815003. I rounded it to 0.6, which made it go a little over 4 because I rounded up. Okay, next 2. Can I erase? Shh, pay attention. Alright, B. How do we get rid of the E? We're trying to get x by itself. So first we need to get rid of the E. How do we do that? Take the natural log. Remember, they're inverses, so they cancel each other out. But whatever you do to one side, you do to the other. So I take the natural log of 14. These cancel. 2x now equals the natural log of 14. Some of you are not paying attention. Now what do I do to solve for x? Divide by 2. Now this is very important. I see this mistake a lot. This is not the natural log of 7. This is the natural log of 14, all divided by 2. So watch when I type it in. The natural log of 14. It is very, very, very important that you close the parenthesis here. That way the calculator knows that you're dividing all of that by 2. Because otherwise, if you don't close the parenthesis, your calculator thinks you're taking the natural log of 7. And do you get the same thing? No. So you have to close the parenthesis after that 14. And your answer is 1.3. That's where checking would come in handy, because if you typed in 1.9 for the x, it would not be 14. If you plug in 1.3, it would be close to 14. Okay, E. Any ideas how I'm going to get this x by itself? It's currently in what kind of form? So I need to change it to log. So, and it's common log because my base is 4, not an E. So, base 4 of equals, right. Okay, well what is log base 4 of 16? Just type that in first. Okay, so you end up with 2 equals x plus 1. Now to solve for x, what do I do on both sides? Right. And then checking this one is pretty easy. You can just do it in your head. If x equals 1, I would replace the x with a 1. 1 plus 1 is 2. Isn't 4 to the second power 16? Okay, can I erase? Alright, C. C is currently in what form? Log. So I need to change it to exponential. What will it look like when I do that? Okay, let me say this one time. This first thing, like 5, stays first. These two just flip-flop. The 2 comes over here, the 4x plus 3 goes over there. That's how it always works. The first number stays first, the other 2 flip-flop. So now what is 5 squared? 25. And now we just have a 2-step equation. To solve for x, what do I do first? Right. And so what is 22 divided by 4? 5.5. Okay, on this test, Wednesday, checking is very crucial to making a good grade. Okay, so at this time, you would plug 5.5 in here and type in log base 5 of 4 times 5.5 plus 3, and your calculator better say 2, or you better rework it. Or you better start plugging in choices till you get the one that makes the 2. Okay? Alright, F. What form is it currently in? Log. Well, what's the base? 10. So if it's in log, to get x by itself, I need to rewrite it in, so what would that look like? Right? When you start to think of it the way I told you, like the first number stays first, the other 2 flip-flop, it's easy, isn't it? Okay, so what's 10 squared? 20. And now to isolate x, what do I do on both sides? Right, and so x equals 97. So to check that, you would replace this with a 97, add 3, type in log 100, see if it equals 2. No. Next page. Number 12, solve 5 raised to the x minus 2 equals 14. What kind of form is that one currently in? So we need to change it to log. Same thing applies. The first number stays first. It just goes down subscript. These two switch sides. So 14 comes over here, x minus 2 goes over there. Okay, now you just evaluate that. Go ahead and type that in. Okay, what is log base 5 of 14? 1.6. And now to isolate the x, what do we do? Add 2 on each side, and so what's 1.6 plus 2? 3.6. Okay, for 13, what form is it in? Exponential or log? But right, the base is e, so you take the natural log of both sides. And so those cancel each other out, leaving x plus 4 equals the natural log of 15. To isolate the x, what do we do? Subtract the 4. Now, what do you think is going to be important when you type it in? Close the parenthesis before subtracting the 4, because it is not the same thing as the natural log of 11. Negative 1.29, which is negative 1.3. Okay, 14 is currently in what form? Log. So we need to change it to exponential. Quickly, tell me what that will look like. Good. What is 4 squared? And then now we just have a 2-step equation. What do you do first to isolate the x? Add the 1, and we end up with 17 equals 2x. And now to isolate the x, you divide by the 2, so what's 17 over 2? 8.5. All right, number 15. Expand or condense the following logarithms. These two are already condensed. Anytime you see log written once, that's condensed form. If you see it written more than once, it's expanded. So if it's already condensed, we need to expand it. How many times do you think I need to write log base 5? Twice. Once for the 2, that's part of that product, and once for the x, that's part of that product. And since it was a product, when you expand it, you do addition. Okay, so what would the answer be for B? Right, that's all you do. Okay, so for C and D, they've already been expanded, so we need to condense them, which means we write them as a single logarithm. You write log once, and it's base 4 for this one. If it was subtraction over here, then when you condense it, it's going to be division. And what's the numerator? A is one that first, and then B. And the 3 was, the power was, remember, it was the exponent that got brought down to the front. So what's the answer for D? Log base 3. Okay, but what have we not dealt with? This 2 was the exponent for the x. Okay,